Okay, let's start with the third lecture video about variables. So I said if we have a variable of type integer called x, initialize it to 10, semicolon at the end. In the memory of the computer, so this is my program basically, and it's inside of the RAM, inside of the overall computer memory of the computer. I'm going to have x here, and the value inside of x is 10. So I could have a variable of type double. So double y equals to 2.5. So I'm going to have y, the value of which is 2.5. And don't forget that doubles occupy more space than integers. In processing, integers have 4 bytes of memory, whereas doubles have 8 bytes. This is largely transparent to the programmer, unless you're working with really large values. But the most important thing is that integers are whole numbers 1, 2, 3, 4, 5, 6, and doubles are real numbers, so they can have decimals. So I can actually have, or they could not. I can actually have a double. Let's say another double, 11. So here A is still a double, and it's going to be saved as 11. In reality, one thing that's going to come in, we're going to work on this a little bit more, but in reality, what happens is 11 is actually saved as a double as something like 11.00001, something like that. Doubles aren't very precise, and this comes into play in the future topics that we'll talk about when we're trying to compare numbers. One thing you have to pay attention to, though, it's still 11, it's just not saved as precisely, whereas an integer is saved very precisely. Let's have another, let's say integer of type let's call it b, and I'm going to have b here, and what's inside of b? It's garbage. Nothing is inside of b right now because I haven't assigned anything. Here, if I go b equals 15, then I'm going to assign the value 15 to b. This becomes 15. So now we know two types of variables. We know ints, we know doubles. Floats are the same as doubles for the most part as far as we're concerned in this course. So I could have, let's say, float and z would contain 2.6. Another type of variables is chars. So chars are 1 byte or 2 bytes in some systems. Basically, what they hold is they hold a character, only one character. That means that if I was going to declare a char, so let me just be consistent with my colors. I'm going to change. So if I wanted to declare a char, it would be char ch. If I wanted to declare it, so I could have only one character. What's a character? A is a character, B is a character, question mark would be a character. This is just one thing, and that would be, let's say, lowercase a. Notice that I have single quotations. So single quotations are extremely important. So single quotations, because that's how you would denote what goes inside a char. So basically a char would only be 1 byte, and right now it would have the value of A. Now I'm just going to leave chars there for the time being. I'm going to talk about them a little bit more at a later date, but basically they are a container, because that's what variables are. They're containers. Chars are a container that is capable of holding only one character. So that's we'll just leave it at that for the time being. All right. So we're through with this example, and let's look at these numbers then. So if I have value 6, you would automatically save it as an int. -6 also as an int. If we have 0, 0 can be an int basically. 0.5 it would be a double. By the way, any of these numbers could be saved as a double as well. However, as I mentioned, they're not going to be saved as precisely. 0.5 cannot be saved as an integer because it's a real number. 1.0 can only be saved as a double. So it's actually incorrect to say int x equals 1.0. That's not what you want to do, because you can't have decimal. You can have scientific notations for doubles, and as you see here, you cannot have a comma in the numbers. You cannot also have fractions. So instead, we can use 3.5. All right. One more concept I would like to cover in this video, and that's the concept of finals. So a final is essentially a constant. So there comes a time in computer programs that you would like to have a value that cannot be changed. For example, on top of your program, you want to have a variable that would contain the value of pi. And that's where you would use the term final. So when you put the term final, the most important thing is you cannot change the value after it's been initialized or assigned. So it's basically set in stone. And the keyword is final, and then the type, and then the identifier, and then the value. So let me demonstrate what I mean but in processing. So up here, I could say int x equals 10, right? And then I could say x equals 5. Let's run this program. It works. Nothing's wrong with this. What about if I said final int a equals 10? Then I say a equals 5. And this doesn't work because it says a final variable cannot be assigned. It must be blank, not using a compound assignment. So basically, once you assigned a final once, you cannot reassign it. So let's say I didn't initialize the final, and let's run it now. It works, but if I try to reassign a, so right now if I try to reassign a to, let's say 23, again, it won't work. So a final is a variable that is well, it's not a variable. A final is a data container that its value is set in stone and you cannot modify it. And there's good reason for that. It's just values such as pi, such as e, such as, let's say, minimum wage that are not going to be changed for a very long time, or as case of pi, they'll never change. So in your program, you don't want to assign them to a variable, you assign them to a final value or a constant value, as they call it in some languages. So that's it for this video. I'm going to continue on doing a video on modifying variables. Thank you.